Good afternoon friends. Today we are going to see about conductometric titration. Let's know about what is titration. It is a process of determination of concentration of unknown solution by using solution of unknown concentration. It is called titration. Now see about conductometric titration. Conductance of unknown concentration solution is measured. Concentration is directly proportional to the concentration of unknown solution. This is the basic setup of the conductometric titration. A beaker filled with electrolyte solutions, a glass rod is used to stir the solution. A electrolyte is placed there. It is known as conductivity cell. A electrolyte is connected to the conductivity meter to know the numerical value of the conductance. A burette is placed there. A burette is filled with the standard solutions. There are 4 types of conductometric titration. Strong acid, strong base, strong acid, weak base, weak acid, strong base, weak acid, weak base. This is the strong acid, strong base, HCl strong acid, NaOH is strong base, which react with form H2O and a Na plus Cl minus. The beaker contains strong acid, the burette contains strong base. When you treat strong acid with a strong base, then we get this graph. On the y-axis is conductance and the x-axis in the ml of the titrant added. So initially in that conductance value is high. As we go on strong base in the strong acid, the conductance start decreasing. The conductance decreases up to this point, and afterwards adding the strong base, the conductance increases. This point is known as the end point. Here the H plus ions have the higher ionic mobility compared to the Na plus ions. So the H plus is react with OH and it gives H2O. So the conductance is decreases when adding the NaOH solutions and it reaches these endpoints. So afterwards there is no H plus ions. So after further adding the NaOH solutions, the OH minus solutions is again start to increase the conductance. So this is known as the strong acid and strong base titration curve. So the second type we see about strong acid and weak base. The strong acid is HCl and the weak base is ammonium hydroxide. The HCl reacts with ammonium hydroxide. It forms ammonium chloride plus water. Here the burette contains the strong acid HCl and here the beaker contains the strong acid HCl and the burette contains the weak base NH4OH, ammonium hydroxide. When the ammonium hydroxide is treated with HCl, we get the graph like this. Here the Y is conductance and the X is ml of titration added. In the initial point the conductance is high and then the HCl is treated with a NH4OH. The conductance is getting lower and we reach the end point. After the addition of NH4OH, we have the slight increase of the conductance. Here the NH plus ions react with the OH and gives H2O. So the conductance is decreases. So at the end point there is no H plus, and the further addition of ammonium hydroxide, the NH4 plus is depresses the dissociation of NH4OH minus. So there is a slight increases of the conductance. So next we see about weak acid and strong base. The weak acid is CH3COOH plus strong base is NaOH. The weak acid is treated with the strong base, we get CH3COO minus Na plus and water. The beaker it contains the weak acid CH3COOH and the burette contains the strong base NaOH. So in the beaker when we added the strong base NaOH with the CH3CO minus, we get the graph like this. The first starting point we have the CH3, the weak acid is a low dissociation, so the conductance is low. The further addition of the NaOH, we get the endpoint. After we get the endpoint, the further addition of NaOH, we get the high increase of the conductance. So here the Na plus is react with the CH3COO, we get the strong electrolyte salt CH3COO Na. So the NaOH is a strong electrolyte. Here at the endpoint it dissociates completely. So the further addition of the NaOH, we get the rapid value of the conductance, rapid increase of the conductance. So this is called weak acid and stock based conductometric titration curve. So next we see about weak acid and weak base. The weak acid is acetic acid and the weak base is ammonium hydroxide. So the acetic acid is reacted with ammonium hydroxide, we get ammonium acetate and water. So in this beaker we have the weak acid CH3COOH and in burette we have NH4OH. When adding the weak base in weak acid, we get the graph like this. In the start we have the decreases of the conductance. The conductance decreases when we adding the NH4OH up to this point, and that increases with the more the amount of ammonium acetate up to the end point, because the ammonium acetate is a strong electrolyte. After the end point, further the addition of NH4OH, the conductance remains constant. This is known as the weak acid and weak base titration curve. Thank you, one and all.